Let's look at some equations where the variable is a higher power than what we're maybe normally used to. We're used to linear equations in one variable, highest power of the variable is 1. We're used to quadratic equations, highest power of the variable is 2. But what about when the equations have a variable where the highest power is 3 or 4 or 6 or 5? Can we do something to solve those equations using maybe some techniques that we've applied other places? Here's one example. Here's our equation, 2x to the third minus 50x equals 0. This is what we would call a third degree equation. Highest power of the variable here is 3. So we want to see if there's some way we can attack this problem to solve it that might be similar to the way we've attacked other equations. Now, you remember when we have a quadratic equation that's missing the constant, we said that the technique we can use to solve that type of equation is to factor. Because if you're missing the constant term, then that means your other terms have to have the variable. And if they have the variable, that means we could factor the variable out. Well, that's also true here, isn't it? We have no constant term. The only terms we have are terms with the variable. So we should be able to factor a variable out. Not only that, we can factor the number 2 out of each of these terms. So I could take this equation and I could start by factoring 2x out of each of the terms. When I factor out the 2x, that would give me x squared minus 25 in parentheses as the other factor. Each of those terms I divided by 2x. 2x to the third divided by 2x gives me x squared. 50x divided by 2x gives me 25. Well, now I have a quadratic expression that I'm working with. And hopefully you would recognize this quadratic expression, this binomial, as being factorable as the difference of two squares. X squared minus 5 squared. Remember, the difference of squares always factors into the two terms, one with addition and the other with subtraction. X squared minus 25 factors into x plus 5 times x minus 5. And now we can solve this equation. We can find the values of x that will make the left side become 0 by examining each of the factors to see what value of x would make the individual factor become 0. If we let x be 0, this factor would become 0. 0 times anything is 0. If we let x be negative 5, when negative 5 was put into this factor would become 0, and 0 times anything else, no matter what those factors become when we put in negative 5 for x, 0 times those values is going to be 0. Or we could put in 5 for x, which would make this factor become 0. 0 times anything would be 0. So our three solutions to that original third degree equation would be 0, negative 5, and 5, and we were able to factor that equation in order to solve it.